Right, here's all the information for question 5. I've put it in the picture. We need the height BC, this little triangle here. That angle is 5 degrees. This longest length, the hypotenuse, is 100 meters. AB is 100 meters. So we've got a right angle triangle. We know the hypotenuse and we know the angle. And we want this height, which is the opposite. So that's the sine, isn't it? So sine 5 degrees is equal to the opposite, which we can label BC, over the hypotenuse, which we know is 100 meters. We're told AP is 100. So that tells us what BC is then. It's equal to 100 sine 5 degrees. So 100 times the sine of 5 degrees, 8.7155, 8.7155, which is equal to 8.72 to 2D. So that's BC, that's that length there. Now, the distance AQ, A to Q. Right. Okay. Now, AQ, well, we know this angle is 5 degrees and we know this one is 42. So if we think about the angle, I just draw a picture of it. Oops. Just by sketching it actually. I'll just try and use a ruler if I can. Here we go. Let's try and sketch Q, C, A. And we'll put what information we've got for that triangle then. So that's what we're looking at here. That's Q. That's C. B, rather. And this is A. And the next thing we want to find out is AQ. A to Q, this distance here. So this angle in here, we know this distance is 100. Okay. So we know, do we know this angle is one question. Do we know that angle? And then we should be able to work out that, because we'll be able to find that angle. And we should be able to use the sine rule. So first of all, this angle in here then, well, there's 42, that less 5 is 37. So that angle there is 37 degrees. See it? 42. Less the 5 is 37. So that's 37. This angle here, if you look at it and draw that line along, if that's 5 degrees, this is 5 degrees. And this is 180. So this is 180 less 45 plus the 5 degrees. So this angle in here is 180 less 45 plus 5, isn't it? See, the 180 is the flat line. This little thing in here is 5. So it's 180. Let's cut off the 45 and add the 5. Minus 40 is 140. So it's 140 degrees. So if that's 140 and that's 37, that's 177. So this angle in here then will be 177, 3 degrees. Just 3 degrees. Okay, so now we got that, we can work out using the sine rule. So this over the sine of this. So AQ over the sine of B, which is 140, is equal to 100 over the sine of 3 degrees. So AQ then is equal to 100. Move the sine 140 up over sine 3 degrees. So that's AQ times sine 140 divided by sine 3. 1228.19. So it's 1228.19, wasn't it? 195, so it's 0.20. And that was to 2 decimal places. That would be meters. because we're working in meters. Okay, there's a Q. So now the third part of the problem is PQ. So we got this triangle here. We know that this is now, that distance is known. Okay, well this is 45 here, so that's 45. This is 3 degrees, isn't it? Because we just said that it was 3 degrees from this triangle here. That's 48, so this would be 132. Because that would be 180, wouldn't it, all three of them? So that's 132, we know that side. Now, do we know this angle in here? If you look at it, that angle is just the difference between 42 and 50. So this angle is 8 degrees. It's just the difference between that one and that one. It's that little smidge, 8 degrees. So if that's 8 and that's 132, this has got to be 40 degrees. Because they add up to 180. So again, we can use the sine rule. 40 over this is equal to PQ over that. PAP. PQ is what we want, rather. PQ over that. So let's do it here. Here, PQ over sine of 8 is equal to AQ, which we know, over the sine of 40. We've got that in the calculator, so we can be nice and accurate. So PQ then equals AQ, which we know, sine of 8 over sine 40 degrees. So I'm just going to type it in here. So AQ is this distance here, answer, times sine of 8 divided by sine 40. 265.9, 265.5, and that's as accurate as can be. 265.92 meters to 2 dp. And we maintain the accuracy all the way through the question.